All right, let's go to the k closest points to the origin. Given an array of points where point I it has an x and a y coordinate pair, represents a point on the xy plane and an integer k. Return the k closest points to the origin, which is 0, 0. The distance between 2 points on the xy plane is the Euclidean distance, so square root of the sum of squares. You may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. Okay, so this one is gonna be pretty simple. It's more of a check of knowing what data structures to use. So in general, if you want to find, say, the kth closest point to the origin, so just a single return value, that would be linear time. Same thing for finding if you have an array and you want to find the max or the min or any particular rank therein, so like the median or the 75th, if you want to find a single one, that's generally going to be linear time. It's when you start looking at getting multiple of them that it starts to get to be kind of worse. So the basic overview is you're going to throw everything into a priority queue or a min heap, whatever terminology your language uses, and you're just going to pop the first k elements off of the top of it. And that's pretty simple. So populating a heap takes linear time. Let's get into it. So it's going to need, in C++, that's going to be a priority queue. So that's in the queue header. Oops, include. And whenever compilers start to support C++ 2023, the standard library is going to be using imports instead of include. Like, it'll still be backwards compatible, but long term, the C++ folks are looking to kill the pre-compiler. So that instead of hashes, you'd be using include statements. That's neither here nor there, and that is certainly not a released version yet, and it'll be even longer until compilers enable it by default. But, okay, so we've got our queue, and another thing we're going to need is, so we're given a vector of vectors, so each coordinate pair is done as a vector, as opposed to an array or a pair or a C-style array or anything else. We're going to need a custom comparison function, and we're going to do a comparison function by distance from the origin. So that's going to use exponents, so I'm going to use the pow function for power. You could type it out manually, it kind of depends, but if you did want to use that, that's included in the CMath header. Anyway, so we need a couple of things. There's 2 steps. There's throwing everything into the priority queue, and then there's popping things off of it. So we're going to have queue, so that's going to be priority queue. And the template arguments they're crazy. So the first argument is the base item, so this inner thing, so vector of integers. The second argument is like the container of that, so it'd be a vector of integers. And the third thing is the type of the comparison function. What I like to do is, if I'm using a custom comparison function, I like to just use the declare type keyword and then put just the name of the lambda in there, and then that kind of takes care of it. So what is this CMP? We need to define it. So for lambda, I'm just going to use auto. I know auto is not... It's better to know what the auto resolves to, but it's a little crazier than I think necessary when you're in an interview setting. Time matters, so you could just do... Oh, anyway, so it's a lambda. So how do you define lambdas? First thing is bracket. whatever you put in these brackets is variables from the outer function that you want to be available in the lambda. So if I put k, then k would be available inside the lambda. I don't need anything, so I'm going to leave it blank. And then parentheses for the explicit arguments. So what are the two arguments going to be? It's going to be 2 vectors of integers, a and b. So what does the function do? Well, we need to do our comparison, and we need to return whichever one is closest to the origin. And we want it to return true when A is closer, and we want it to return false when B is closer. So A would mean the left argument, B would mean the, true means the left argument, false means the right argument. So how do we do that? So we need to do this Euclidean comparison. Now, we don't necessarily need to find the square root, because the square root doesn't change the relationship. We can just do the sum of squares. So we can do return, so power of power of the first element, so A, and that's going to be the difference. So x squared, the distance from A to the origin is the x value minus, so 1 point minus the other. I'm always comparing against 0, 0. So A of x minus 0 squared plus A of y minus 0 squared. So it's gonna be, let me see if I can think this through right. So yeah, just difference of x is difference of y is looking at that. It's difference of x. I suppose, yeah, you could just do times, but sometimes this library function is going to be faster. It might be slower. Whatever is most restrictive is generally going to be faster. So a squared plus, yeah, at this point I'm just illustrating the power function. So power, probably didn't need this in hindsight. And then we want it to be true if we want to turn to left. So it would be priority queue. I can't remember if I'm getting it. I think it'll put the lower one, so higher priority. I'm pretty sure it starts out as a max heap. I might have to flip the signs. I'll have to check on submit. Greater than, I'm gonna get rid of this. And I'm just, yeah, cut my losses. Times A0 plus, keep it syntactically simpler, reduce the need to import a library. B0 times B0 plus B1 times B1. So that's our lambda, and again I may need to flip that sign depending how it works. So then how do we initialize the queue? Well, it's also, this one's also kind of weird. It's not a constructor. You'd initialize it like kind of an array. The first argument in these braces, instead of parentheses, is the comparison function, and then the items you want to populate it with. So it's going to be points. When you have an existing array and you want to turn it in to like a priority queue or a heap, it can do that in place. Or I guess in here, it'd probably be copying it over in this case. But either way, it's going to be linear time to make the priority queue. And then anytime you add something to it or remove something from it individually, in order to maintain that, relationship of ordering so that the first is always like the desired one. That's going to be logarithmic time on the number of items. So in this case, we have all n things in the queue, so it's going to be log of n time to push things or pop things off of it. All right, so we've got our priority queue, we've got our comparison function on our main data structure. Now what's left is to take the first k things off and return it. So let's make our output a vector. It's a vector of integers. And ret for return. And we want it, instead of like pushing things on, it's slightly faster to initialize all the memory at once. So it's going to need k things. And we're going to populate all of them, so we don't have to give them a default value. Doesn't super matter. So then for int I equals 0, I is less than k. I suppose we could just decrement k, but does not matter. All right, so then return of I equals q, what did I call it? Yeah, it's just a q. Q dot top, and then C++ makes you do it in two separate calls. This pop returns void, so you can't set it there, you have to call top. And I think yeah, so like I said, this is mainly about just knowing the data structure, and it's not really about the algorithm. So first I'll step through runtime and then an example. All right, so it's O of n time to, this is just to make the priority queue, it's to make to populate. Oh my gosh. O-R-I-T-Y, queue. Populate the priority queue plus O of, and then we need k things of log of n operations each. Time to get the first k things. So it's k, top k elements, log of n per thing to pop it off. Log time each. Log of n. So generally, I like to write my run times and maybe some other notes on the problem itself and some comments. That way, it's not relying on the interviewer's memory, because they're people and you don't want them to. They do their little write-up after you're done talking. They might do some typing, but it's generally they're going to do the main write-up after you hang up. So you don't want to count on them remembering, oh, did we touch on that factor or this one or that one? Anyway, so yeah, pretty much. I'm not going to step through an example here. Normally you should, but this one's so simple. It's just putting things on the queue and then popping the first k things off. And then, oh yeah, I should mention the space complexity. So it's going to be O of n space, since we're using the queue and the queue is making a copy constructor. Uses copy constructors. And that just means it's not, we could use the input itself. That's certainly doable, and depending on your language, and C++ does have functions to do that. I would not recommend using the kind of lower level API that the priority queue uses under the hood. In an interview setting, I have tried doing that because I was adapting what I'd learned in Python, which has their lower level API is very similar, but it's a little more user friendly. And so I tried to adapt that for an interview where they were asking about like the merged k sorted arrays sort of question. I did not leave myself enough time. This priority queue API is the way to go if you're using C++ in an interview. So then let me give it a run. Hopefully I got this direction correctly. What did I miss? Oh, semicolon. Another typo, forgot an E. Cool. Okay, so I did get the directions. So yeah, when you have the priority queue, whatever you want to appear, I guess last, because if this sum of squares is greater, that means A is farther, and we want the k closest points to the origin. So whatever is going to appear first on the queue, if we want the left argument to become first, we need to return false. And if we want the right argument to return first on the queue, we need to return true. So this is about greater than-ness. Okay, that makes sense. Submit. Fingers crossed. All right, cool. Check it off our list, and we're done. Thanks.